In this video, I am going to look into LeetCode linked list cycle problem. Let me read the description. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Okay, so basically they will give a head of a linked list, or you need to find out whether it contains a cycle or not. Here you can see a graph they have given which contains 4 nodes, and here you can see the last node connected to the second node. So basically it contains a cycle. Another example is this one. This also contain cycle. Third example, only one node they given, and there is no cycle they shown here, so there is no cycle there. Constraint, and the number of the nodes in the list is in the range 0 to 10 raised to 4. A node value pos. Basically, pos is just for demo purpose they are given. Pos 1 means cycle connected to first node. 0 means it's connected to 0th node. Minus 1 means it's not invalid index, which means there is no cycle. That's all. So let me show the. I'm going to solve this problem in 3 ways. First is a hashing. You can see the timing is linear time. It needs a linear space also, and second method is a random node caching for comparison. I will explain what it is. This one here also time is linear, but it required only a constant space. And third is a Floyd slow and fast pointer. So here you can see in random we don't know exactly how much time it needed, but in the Floyd slow and fast pointers it's a linear time. There is no randomness here, and space is a constant. So basically this is the best approach because the first one needed a linear space on, and here we are not sure how much time it will take. So Floyd's is the best method, but let us start with the hashing first. So here they given it's a Java class, and this is a method. They will pass a head here, so we need to return whether which contains cycle or not. You should return true if it contains a cycle, otherwise false. And here you can see the class of list node, which contains a value and a next pointer, and how to initialize that list node. Basically value, actually we won't use value at all. It's basically confusing. We won't use the values. We can use the value some way, but it's better consider there is no value. Okay, we don't need that. So how to solve this one? So to solve that one, we need to go through each node. So what you can do is that while head should not be null. So we reach it in the first one here. Then we need to next node. So for that, what you need to do is head is equal to head dot next. So this will create a loop. It will continuously going through the head, and it will break if the last node contains a null as a next pointer. They didn't give an example here. They give an example for this single node. Next pointer will be null. So in that case, this loop will break. Then you can return false because it doesn't contain cycle. So what the problem here is that one if cycle contains, this loop will iterate forever. So what we need to do is that one, we need to check if we found a repeating node, then you need to return true as a we found it contains cycle. So here you can see the 2 is repeating. You will go through 3, 2, 0, 4, then you will come back to, which means it's we found a repeating node. So we don't know how to find this one. Okay. So for that, what we need to do is that one approach is the first approach. It's a hashing. Basically, we will define hash. Here we will the type is we are going to store this node address. Set new hash set. Basically, we defined a hashing. Now, I will add this at the end. So here what we will do is that one, if we found a repeating node, if set contains head, which means we already saw that node, then you need to return true. Need to return true. Otherwise, you need to add that head into set. First, we will check whether contain or not. If it is contained, it's true. Otherwise, you just add the head. Then move to next pointer. Okay, I hope this code is correct. Basically, what we are doing is that we created hashing here, and we are going through the each node. Every node we will check whether that hashing contain that node. If it is contained node, means it's a cycle. Otherwise, we will add that into. Then we will go to next. Let me try and check it whether it's working or not. Compiler, okay. Yeah, accepted. Let me submit this also. Yeah, correct. Fine, it's working. Basically, what we have done is that we created a set and we stored that one. Every time we will check that one. But here you can see that one timing is linear, but space we needed linear time. So hashing is because of the space problem, it's not optimal one. So let us do one thing. Let us go to another one. What I will do is that one, I will add a random node. Random node. I will add null. So basically, what I will do is that one. I will use a random. Basically, what we want is that we need to store any one of the node inside this cycle, and we will store in the random node list. And here we will check head is equal to random node. Head is in random node, then return true. We'll remove this one. This is the idea. We need to get one node, a random node inside the cycle. That's a challenge. How to get inside that challenge, because we don't know when we will reach into the inside the cycle. Maybe first there are hundreds of node will be there, then 2 coming 0 4 like that one. So we don't know when we will reach inside this one. So that's a challenge, how to get this random node. If we got that random node, we can check like this: if head equal to random node, which means we fixed one node inside the cycle and we got head reached to that point. Otherwise it will loop forever like this, then you will return this one. So what I will do is that one, I will define a random, and here I will do one thing: if a random dot next int equal to 1, then assign that head as a random node. This is just for testing purpose, it is not efficient method. So here you can see how many nodes are there, 10 raised to 4. So I will give a 10 raised to 4, right? Means every one cycle it will probabilities it will change the value of random node. Every cycle will change the value. The reason is that maybe we store 3 in the random node, so we need to change that one to some of the node inside this one. So this is the idea here. If it is 1, we will add random node head. Let me test the code. Okay. We found 4 ms. So you can change this number to a little 5000. It's difficult to find out to come up with a very good number here, but you can see now 3 ms. I will explain once again. The idea is this one: we need to get to one of the node inside this cycle, but we don't know how to get that one, because there can be multiple node before the cycle, so we may assign one of them. So the idea is this one: we will write some random code that will routinely change the value of the random node, because maybe we added 3, maybe intermediate may be added, but once it is reached inside the cycle, it will loop forever. So because of that, in some point it will assign the head may be any one of these 3. Currently is 3, it may contain thousands of nodes, so it will assign one of them. Then at the time of looping it may match. It's basically a random algorithm. It may not work always, but probability is very high to work. So this is the idea. We defined a random node and we assign a value in a probabilistic way, and we checking whether the node we are going through matching the random node, then true. So here the problem is time is not you can't predict the timing. Now we will go to Floyd's slow and pass pointer. Here timing is linear and space is constant. So I will clean up everything here. In the Floyd's slow and pointers method, what we will do is that we will define 2 pointers. One is a slow and one is a fast. Slow head, I will assign head as a first value. Fast, I will explain how it will work later, but let me write the code first. First you need to check while fast is not equal to null and fast dot next is not null. If any of the value is null, which means there is no cycle, node is ending, so obviously there is no cycle, false. So inside this one, what you need to do is that one change the value of slow to slow next, fast dot next dot next. So here you can see we are checking whether next is not null, so you will get this value, but it may, this next value may be null, but this value next won't be null because we are testing here. Now if slow equal to fast, which means we found a node inside the cycle, return true. Okay. Okay, we checking this one. Let me test if the score working or not. Accepted. Okay, 100% beats 100%. Okay, I will explain. This is the actual code for this Floyd's slow and fast pointer. Basically, we will define 2 pointers, slow and fast, and we will assign head as a first value. Then we will check fast is not null and fast dot next is not null. If any one of the null means we found the tail node, obviously then there is no cycle. Next is change the slow node to, basically this is a 2 pointer, slow and fast pointer, slow dot next, but fast should jump one node. Basically see here slow, you can see it pointing next node, but fast points next to next. Then we are checking whether it's matching or not. This is the algorithm. I will explain how it is actually working. Assume that U contains only one node. Okay, then both the slow and fast will point to 1 first. Okay, then the value of is, assume that this node 1 contains cycle, which means node 1 dot next pointing to node 1 itself. So it will enter inside this one because node 1 is not null and the node 1 dot next is pointing to node 1 itself, then both are not null. Then we will change the value slow to slow dot next, fast is to fast dot next. So here what will happen is that one slow is 1 because here you can see slow dot next, basically it's pointing same node itself. Slow is 1, and what about fast? What will happen fast is that fast will point to 1, then again point to 1. So fast also will point to 1 only because this node 1 dot next pointing to node 1 itself. So here we are checking next to next, basically it will get 1 both. So it will match and you will tell, yeah, there is a cycle. It will be a bit confusing. Okay, anyway, let us assume 2. There is another input. There are 2 nodes are there, node 1 and node 2. Node 1 pointing to node 2, node 2 pointing to node 1. In that case, after this computation, slow will point to next node. Next node is 2 here because both are starting from first. After this first part, slow will be 2, and fast first starting from here, it will point to next to this one. This will point next to 1, so fast will be 1. So there is no match here. Now next iteration, the slow will point to next. It's currently slow is in 2, next is 1, it become 1 here. Okay, fast is currently in 1, its next is 2, next is 1. So here we can see fast next. This is the first next, this is the second next. Then you will point to 1. Now you can see that slow and fast is same, and it will detect the cycle. Now let me example with the 3. So in this case, what will happen is that in the first iteration, slow will get to 2, and the fast will get to 3. Because both are starting from here, slow will point to next, fast will point to next. Slow will point to next node 3, fast will point to next. 3's to next is 1, 1's next is 2, it will show to 2. Third iteration, slow will point to 1, fast is right now in here, 3 is next, and 1 is next. Then it will show here 1. Now you can see here it will match 1 and it will return. In the case of 4, I won't explain, I will just type here. Here it will come 2, 3, 4, 1. Fast will start with 3. There is no 4, 1. There is no 2, 3. There is no 4. There is 1. So now you can see matching. You can notice that one here. It's 4. 4 is the number of nodes n. So basically, it's exactly time is O(n). It's matching every time O(n). It will match the same node. Okay, that's a explanation for this Floyd's slow and fast pointer. That's all. Thanks for watching.